The traditional view of cancer is that it is a result of mutations within the nucleus, that it's purely the genetics, what's called commonly the somatic view of cancer.
I believe Dr. Ben Bikman saved my life. He miraculously got brought into my life. So a little context with Dr. Bikman, he is a metabolic scientist at Brigham Young University. You were a huge part of my cancer not growing to the point where it got out of control. 2 doctors ignoring me.
Many breast tumors, if they undergo a genetic analysis, will have up to 7 times more insulin receptors. And this matters because one of insulin's thematic effects throughout the entire body is that it tells cells.
I am so excited because Dr. Ben Bikman, I honestly feel like you saved my life, and I am so honored that you miraculously got brought into my life. And so a little context with Dr. Bikman, he is a metabolic scientist at Brigham Young University. He has a whole research lab and book dedicated to beating insulin resistance. I got on a podcast with you in 2020.
Sounds
I don't
right.
know, somewhere in there. And on your podcast with me, you were teaching me about metabolic health, and you said, this can affect, the prevention of certain cancers like breast cancer. And I had breast cancer and I didn't know it. And it was so miraculous to me that we happened to get on this podcast. Your research is so compelling to me. I switch everything. I put on a glucose monitor with you and Casey Means, like obsessed with it. And I truly believe because of that, you were a huge part of my cancer not growing to the point where it got out of control because 2 doctors, were ignoring me. Anyway, so your research for the cancer community, I feel like is truly, divinely inspired. And I'm just so excited to talk to you about how metabolic health really plays into, cancer prevention, cancer, growth, all the things.
Yeah. My pleasure. I mean, what a warm, lovely introduction. I am just so thrilled still to see you doing well. Yeah, when I started, I was off the air. Raleigh and I were talking about some of my frustration with academia, where on one hand, Raleigh has a book about sort of follow your gut. Raleigh, you would explain it better than me, but sort of challenging the norm in a way. I have long felt that same push myself within academia, which has a lot of lovely little things to it, but a lot of big problems, like it being content to be irrelevant. After I got tenure at BYU, I looked at the rest of my career and thought, do I want the rest of my career to be defined by metrics that don't really matter in the real world? Like, how many papers did you publish? How many other scientists are citing those papers when they're publishing their work? What nonsense this is. Now, I appreciate the metric as a tool of measuring success within academia, but at the same time, it seemed more and more to be like monopoly money. And I wanted to step into the real world with some of these ideas. And so it became a bit of a labor of love and just satisfaction to determine the degree to which metabolic health acts as a common soil hypothesis for so many chronic diseases. And that is what got sort of built into the book that Raleigh has there, the Why We Get Sick, which is my effort to sort of present an alternative view of chronic disease, that as much as an average individual will look at their type 2 diabetes and their hypertension, their Alzheimer's, indeed, even their cancer in some instances, as totally unrelated conditions, I presented this view that, well, despite whatever individual origins they may have, they at least all share one, which is this common metabolic core. And in the case of cancer, it's actually a much longer studied topic than people think it is, with the furthest evidence going back to pre-World War II from the work of a scientist by the last name of Warburg, who won the Nobel Prize. And in fact, his contributions to science were so recognized even at the time that despite being Jewish, Hitler let him stay in Nazi Germany and continue his work. That was how prized his work was considered, that even Hitler was willing to sort of put his bizarre, horrific standards to the side to let the scientist continue to do his work. So Warburg was the first to posit this idea that cancer is a disruption of metabolism. And he identified this process, which is named after him to this day, called the Warburg Effect, whereby a cancer cell has such a preference for glucose, blood sugar, as a fuel, that if you deprive it of that fuel, it becomes incompatible with life of that cancer cell, and the cancer cell cannot grow like it wants to, and indeed can't even maintain itself. So my view within Why We Get Sick, what I articulate is this sort of twofold approach, or this twofold aspect, two sides to this prism of cancer, which is the insulin and the glucose. So the glucose side, I kind of articulated with the Warburg effect, that cancer cells have a preferred fuel and use it 10, 20, 30, multiples higher than normal cells do. So this huge reliance on blood sugar. But at the same time, they have a signal that tells them to grow, and that's where insulin comes in. In fact, many breast tumors, if they undergo a genetic analysis, will have up to 7 times more insulin receptors than normal cells will. And this matters because one of insulin's thematic effects throughout the entire body is that it tells cells to grow. That's insulin's natural, normal signal to a cell. And when you have a cancer cell that is able to respond 7 times more to that growth signal than another cell, it's going to grow. So you have this, like the two aspects being the elevated responsiveness to insulin, wanting it to grow, let's just say 7 times more, given that it has 7 times more insulin receptors. But at the same time, we have the average individual now globally. I was tempted to say the average American, but it is the average global citizen now, who's eating about 70% of all calories from carbohydrates, and they're eating 6 times a day. The average individual is existing in a state of almost constant hyperglycemia and hyperinsulinemia, because anytime glucose spikes, insulin spikes. So they have this elevated insulin signaling the growth of the cancer cell. But then, of course, the cancer cell would say to insulin, hey, insulin, you're telling me to grow, but what am I going to grow with? Oh, here's all this glucose that I can use as a fuel to fuel the growth. And so I'm going to keep growing. And it's basically like in the marathon of metastatic growth of the tumor, we are putting ourselves metabolically in the perfect situation to basically give the cancer cells like aid stations, where we're telling the cancer cell running this marathon, metabolic marathon, hey, cancer cell, you're getting a little tired? Well, here's some Gatorade so you can keep growing and killing me. Now, that's the view that I articulate in Why We Get Sick. But then, at the risk of really speaking too much here, let me just articulate the work from Dr. Thomas Seyfried that I know you two are very familiar with. Dr. Seyfried in Boston has really taken up, more than anyone else, the torch that Dr. Warburg originally sort of lit and ran with for so many decades. Dr. Thomas Seyfried is sort of nowadays the modern equivalent of Dr. Warburg in the past, where Dr. Seyfried's work continues to look at metabolism, but most especially at the mitochondria. And I just have to articulate some of the work that he's done because it's so fascinating and totally changes the paradigm of cancer. The traditional view of cancer is that it is a result of mutations within the nucleus. What is called that is purely the genetics, what's called commonly the somatic view of cancer. And somatic just sort of touches on a deeper idea of cell biology. So suffice it to say, the traditional view is that within the cell, you have the nucleus, and within the nucleus, we have all the DNA and the genes that generally determine who we are, and that's where the problem is. So he proved that totally wrong in a beautiful set of experiments. He had on one hand cancer cells and on the other hand normal cells. And he said, okay, if this is a nucleus and gene problem from the nucleus, then if I move the nucleus over from the cancer cell and drop it into the healthy cell, which he can do, then this cell should suddenly become a tumor cell. And he did this, and it didn't happen. Wow. The cells were normal cells. They grew normal. They died normal. However, he said, if it's a metabolic problem, if I do the same thing with the mitochondria of the cancer cell, then I should see a problem. So they took the mitochondria from the cancer cells, inserted them into the healthy cells, and wouldn't you know it, supporting the metabolic view of cancer, those cells suddenly became cancerous tumor cells, really proving positive that this is not only a mitochondrial problem, but it's a metabolic problem. And of all the various aspects of cancer research happening now, some of the most compelling are those studies which are leveraging the metabolic component, again, really headed by Dr. Thomas Seyfried, documenting even in human instances where you put a human into, say, a ketogenic diet, which is sort of the opposite of a sugar burning state. You know, the hyperglycemic glucose burning instance has its opposite, which is more of the kind of fat burning ketogenic state. And we can talk more about ketogenesis if needed. But it's really one of the hottest areas of cancer biology research, looking at the degree to which a ketogenic diet can itself act as a bit of a therapy and act as an adjuvant therapy, complementing what the traditional clinician wants to do, which is just simply get the person on some chemotherapeutics, right. Which, I mean, those are powerful drugs. You guys have some firsthand experience there. I mean, it's basically a poison saying, can enough of you be left after we kill all the cancer to survive? I mean, it's a hell of a gambit. It's a brutal way. So if there's anything you can do to help the person need less of that poison, what we call a chemotherapy, then we want to do it. And that's what a ketogenic diet appears to do. It sort of primes the cancer cells to be very responsive to the cell death of the chemotherapy. So suffice it to say, that's my long-winded way of saying the somatic nuclear genetic view of cancer is sort of, I would say, evolved, but in a way we're remembering discoveries of almost a century ago, which documented this metabolic phenomenon to the disease. So in a way, we're remembering and building on the ideas of a couple generations ago.
Why do you feel, and that was so perfectly well stated, why do you feel like there is such, I guess first, do you feel like there is a pushback for those kind of the establishment on the somatic mutation theory that cancer is a genetic disease with some of this kind of reemerging Otto Warburg, Thomas Seyfried, your research as well? Do you get pushback with the kind of establishment medical community? I know anecdotally, I've heard of patients that are wanting to do ketogenic diets or kind of lower glucose driven diets and are told by their medical team, I think there's usually a concern of, you don't want to be in a caloric deficit with, what chemotherapy is doing to you. Obviously the American Heart Association, some of these big associations state that it's good if you're facing nausea to, just take down whatever food you can, whether that's Haagen-Dazs or not Haagen-Dazs.
Mm-hmm. I have the book on it. When they gave it to me, I was like, Dr. Bikman, you'd be so mad about this.
I mean, to me, when I hear as a non-science driven person, just a lawyer, what you talk about, what Thomas Seyfried talks about, it just makes so much inherent sense to me. And maybe I'm just too dumb for it to, which I don't think is the case. Do you get pushback? And do you think that is incompetence, corruption, greed, some combination?
Yeah. Well, maybe the simplest version of this would probably be coming from, like the most generous view could be that we only know what we've learned or what we've been taught. And having been a professor for 15 years of pre-med students, I am delighted and amazed and sometimes disappointed with the degree to which I get emails from former students who are going through med school and just sort of groaning at some of the information they learn, having seen the data from me. So one of the ways I teach as a professor is I never rely on a textbook. I don't have readings from textbooks. I don't have assignments from textbooks because I don't want this PhD over here telling this PhD what he can teach his students. If I am worth my weight in salt when it comes to being a professor, I'm the authority, not the person who's writing the textbook. So I have developed all of my courses with this primary source research paradigm in mind, where I'm only going to the original peer-reviewed studies, which allows me to challenge the norms, including when it comes to teaching a section on cancer biology. And so I will get an email from students just saying, Professor Bikman, I'm sitting in this discussion of, say, type 2 diabetes or Alzheimer's disease or cancer, and I'm groaning at what I'm learning. So with some sympathy, I look at the conventionally trained clinician and think, if you didn't have a professor who's a little bit of a heretic, who's willing to challenge the norm, then how could you be expected to know these things? And so that's my sort of compassionate angle, which is to kind of give them a little bit of grace and just say, look, I get it. You literally have never been taught this. You've never heard it.
You know not what you do.
Yeah, right. Exactly. And then when you combine that with the little bit, sometimes more than a little bit of ego that comes with having a degree that lets you put some little letters after your name, that's a dangerous combination. And I will say, although we've seen an evolution of this in the past 5 years or so with PhDs, but there's one of the many differences between, like if you look at people who put letters after their names, two of the most prominent are those who call themselves doctor, PhDs or MDs. What I just like to say, scientists or clinicians, to be a little clearer here. Just because doctor is a vague term that actually means teacher in Latin, but it's been sort of hijacked by the medical community. So if we look at the scientist versus the clinician, the scientist ought to have had some humility baked into the process, because we literally, in order to get the PhD, you have to go through kind of a grueling defense. It's literally called the dissertation defense, where you have to sit there as the young PhD candidate and have a bunch of professors criticize everything you've done. And then when I want to get a paper published, even to this day, you'd think, well, Ben is a full professor. He should just be able to publish anything he wants. No, I can literally have a brand new minted PhD challenge my work as a reviewer and reject it from getting published. So there's a lot of humility that ought to be crammed into the PhD's face. Now, again, within the past 5 years, I believe we've seen science, indeed the hard sciences, my area, take a wild left turn into la-la land. But that is more of a political, social commentary, so we'll put it to the side. But with one of the problems with the physician route is they don't have that inherent check,
Right.
where they don't have a colleague who can maybe laugh at their face or reject their work like I do. And so I think that lends itself to being somewhat dangerously ignorant in many instances. And then when you combine that with a patient who may come in very informed, it takes, I think, a very uniquely, inherently humble person to listen well enough to the patient and admit that the patient may know something they don't know. And so all of that having been said, there is room for some compassion, but there's also a growing lack of compassion because the evidence is mounting so substantially. Right. And my view on, particularly as you teed up the question, you'd mentioned the ketogenic diet in particular, and I did too. There's something about that K word that just elicits an immune response from people. Where you just say ketosis, you say ketone, you say ketogenic, and people just lose their minds. They just can't have a rational conversation. So I don't even start with ketones. When I talk about the metabolic problem, I found very early on that if I started with the K word, I would lose them. They were done. Didn't matter who it was. The clinicians, they already knew what I was going to say in their minds, and they were rejecting all of it out of purely just bad information. So more and more in my career, one of the ways I define what I do is I'm not necessarily an advocate of a ketogenic diet, but I'm a defender because there's such nonsense ideas surrounding it. So I have tended to try to present the idea when I speak to clinicians of the metabolic problem being insulin resistance. And just as a bit of a tangent on this topic, we are living in what I hope is going to be a good time with medical and clinical care, where wherever someone's political beliefs are, there's something good about having a disruptor at the head of how we will start to practice medicine within the United States. And so I'm quite pleased by the direction I see. Not perfectly pleased. I think some of the efforts are going in a little bit of a wrong direction, but I'm overall very pleased. We talk a lot about metabolic health. That's an amorphous, undefined, vague term. What does that even mean? And so one of the things I would like, if I could, I would say when we talk about metabolic health, we define it as saying, where are you with regards to insulin resistance? That is, to me, the purest and most accurate way of talking about metabolic health. So just to answer that question more finely, when I look at all of these entities, the American Cancer Society, American Heart Association, American Diabetes Association, what I find continually discouraging is how readily all of them embrace carbohydrates and how readily all of them vilify saturated fats. That is just the standard to them, and it just doesn't make sense to the rational scientist and to the rational patient. Yeah. You look at this and you would say, hold on, American Cancer Society, you're telling me to eat whole grains. And when I have my continuous glucose monitor on, I see that my glucose goes to the high hundreds when I eat a whole grain, whatever. And then when you learn that that's the preferred fuel for the cancer, it starts to, you start to wonder. I don't know why, Raleigh, when you presented the question, is it ignorance? Is it malice? I would say it used to just be pure ignorance. And now more and more, I think that there just must be enough competing interests, enough gain to be had, that in more instances, more and more, it probably is a little bit of malice, unfortunately.
Yeah, I've started writing a little bit, even from the, lawyers have their part to play in this as well, because the standard of care originated in the 1920s as this duty that experts had to deviate from the norm, to do things that fell outside of what their colleagues were doing if they were using their professional judgment. And the legal system would hold them accountable for just doing what everybody else did. But then tort lawyers got so aggressive with doctors in the 1970s, suing them for malpractice, that the standard of care turned into this safe harbor instead of this duty that you had to your patient to deviate from the norm and do your own research. It became this thing that, as long as we document it enough, as long as we get the studies, and as long as we promote convergent thinking, and we just do the same thing, and we all kind of stick to this protocol, then we're all going to be safe together, and the tort system can't come after us. And I think where that becomes a problem is then when the cost to do studies, and I'd be interested in you as someone who has done studies, I'd be interested to know, from the outside, it looks like now the cost to do a study on something like a ketogenic diet, it's so cost prohibitive to get that FDA approved, that to fund that new null hypothesis, for something that can't be patented and can't be protected and can't really be monetized, I think it will widen the chasm between those who are true scientists, who are, truth seekers through the scientific method, and just clinicians that are staying within standard of care and kind of sticking within the orthodoxy.
Yeah. No, in fact, you make 2 points. They're both exceptionally good. The first one, what I ought to have said earlier too, and you prompted this, when I mentioned the compassion that we ought to have with the clinician, I know clinicians who have looked at everything I've looked at and come to the exact same conclusions, and yet say, Ben, I couldn't do this. My clinic would be so sued, I'd have to shut down.
Right.
And so I appreciate the constraints that come with the clinician. As a scientist, I am free to just follow the data and say whatever I want to say about it, because I get paid to ask questions. Mm-hmm. It doesn't pay particularly well, but it's its own career. The clinician gets paid to see patients. So anything that compromises their ability to see a patient, you eat what you kill as a physician. And if you can't see patients, anything that challenges that, like some patient having some kind of adverse event that might not have had anything to do with what you told them to do, boy, they're coming after you and you are in danger. So I get that they have to have a lot more caution than I do. I can just look at the sum of all evidence and just say, this is what it says. Let's just go. They have some considerations that I wouldn't have. But yeah, anyway, so there's that compassion idea, just adding to it. And then the whole idea of ketones just continuing to be shown more and more to be therapeutic, to challenge the norm. I'm optimistic, frankly. It's not going to go away. And there are more and more efforts to continue to bring this to the mainstream. And I think it's happening.
It was so nice to be able to enter chemotherapy with all of your knowledge. If you look at how I responded to treatment, I was following the protocol that, I was texting you about like a year ago, like, okay, how do you actually execute this? How do you actually stabilize your blood sugar? How do you, Ben Bikman, what do you do? And so, from what you told me, you fast in the morning and then you do a health coach shake. And then if you get hungry, and you kind of gave me your little framework that I was following. And if you look at how I did during cancer treatment, I was able to handle it so much better than so many people. And it was because, honestly, I believe I knew exactly how I could hack my energy, protect my cells with things that you taught me. And it made such a difference on how I was able to recover and how I was able to navigate chemotherapy, radiation, double mastectomy, all the things. I really just practiced what you preached, and you can really feel the difference in your energy levels, first of all, and then how quickly that you recover. And so I'm just so grateful for that. And I'm so passionate about your work. Ask Raleigh. I'm always like, nope, Ben wouldn't like that. Nope. Like Dr. Bikman, true or false? Yeah. I'm always like, Ben would not approve of this.
I've cursed you more than once, Ben.
I'm sure. I know. Yeah, I've been the cause of more marital strife than most
I'm
men.
like, nope.
Than most freckled bald men have any right to be. And not for the reasons people would think. I'm breaking up happy marriages, not because of my looks, but because of my brain.
But I feel like you're also saving them because you get so metabolically healthy.
Yeah.
Superhuman, But also one thing that was interesting for me is when you get a diagnosis, people love to tell you about plant-based. And I was like, oh my gosh, I'm so grateful that Ben taught me about this, because I didn't even have to like go down that nonsensical path. It's
Ben, can you
awful.
actually speak? Can you
In
speak
fact,
to
yeah.
the China study and kind
I'd be
of?
happy to. Yeah.
Like,
In
how
fact,
does that
Raleigh,
work?
I just remembered the other part of what you'd said was just you're nauseous. You don't really want to eat. So just eat anything. I don't agree with that. Frankly, I think there was a rodent study that actually looked at what happens. It is a rodent study, and these were an animal model that was designed to get cancer. And the more glucose they ate, the faster the tumor grew. And in fact, when they put them on a ketogenic diet, the less the tumor grew and the more lean mass it had. And as people know, when it comes to cancer, one of the real problems is the wasting. Essentially, the cancer is eating so much that it's depriving the rest of the body of any nutrition. All the more reason to eat nutrients that the cancer cell can't eat, like dietary fat. The cancer cell is not metabolizing fat. It's not metabolizing ketones. So my view would be, well, then I want to eat more of those things. And that's, of course, by nature going to be a ketogenic diet. So within human nutrition, we have the 3 macronutrients: carbohydrates, proteins, fats. And sort of touching, this is getting us to the China study results. Carbohydrates are the one we eat the most of, by far, not even close. At a global level, even within the United States, within the US, it's about 60% of all calories are carbohydrate. And then we have less fats and less proteins. And those, when we look at, okay, what spikes someone's glucose? Carbohydrates do. What spikes someone's insulin? Carbohydrates do. What is the one macronutrient humans actually don't have a biological need for? Carbohydrates. Well, that's pretty awesome then, because those are the 2 you just told me are problematic to my cancer, with the hyperinsulinemia and the hyperglycemia. So what if I just eat less of those? All right, that's a pretty sound strategy. Lest someone think I'm being a little crazy, even the slow-moving, ridiculous entity of the federal government, and yes, I am increasingly libertarian as I get older, has stated with the Department of Agriculture that the lower limit of carbohydrates in humans in the diet is 0, assuming a person's eating adequate fat and protein. So that there are such things as essential fats, there are such things as essential amino acids. There is no such thing as essential carbohydrate. 0, none. It doesn't exist. And to just put a fine point on that, how can you ensure you get those essential fats and those essential amino acids? Eat anything from an animal and you'll get it all. Eat anything from a plant and you won't get them all. You can't. You literally cannot get all of the essential fats and the essential amino acids you need if you only eat plants. And so the whole idea that a plant-based diet is going to be somehow therapeutic when you're eating glucose and you are not eating all the essential things you need for your own nutrition, it's insane. And I think it is, in fact, reflective of just some global ideological capture where we have been raised in such a culture of just adoring plants and fruits and vegetables and grains that we can't challenge that idea anymore. In fact, just to sort of be a little funny here, but I am in fact very religious. Anyone listening, go look in the New Testament, 1 Timothy chapter 4. It is so interesting to see how the Apostle Paul describes the latter days. And I don't present this as me trying to state some exclamation mark and stamp this as all, it's validated by God, so it's true.
Prophecy.
Yeah. I mean, it is just kind of, it's interesting at the very least, where the way Paul talks about the latter days, he said that people will be seduced by the doctrines of devils, which is a pretty dramatic way, I think, of saying people will be confused and misled. One of the things he says about them is that they will command to abstain from eating meat.
Are you
which
serious?
I, the Lord... That's what it says. 1 Timothy chapter 4, I think verse 4. It's pretty remarkable. And again, it's just sort of telling, and it's an interesting thing to look at this idea of our modern world being a little misled. And part of that misled information is this idea that we shouldn't eat meat. And so I reject the idea. To me, an anti-meat diet is an anti-human diet. We are omnivores. And if we tip either direction, we lean more to carnivore in our anatomy and physiology than we do to any herbivore, because we would literally die. If you put a human on a purely herbivore diet, you're dead. You put a human on a purely carnivore diet, you're fine. You'll live perfectly fine life. You're not going to have any early premature death through nutrient deprivation or something. And so now that brings us to some of the more modern research, which is leading the charge, where the China study is essentially the vegan's Bible. The problem with the China study, maybe twofold off the top of my head. One is that it's all of the human data is correlational data. And then even the correlational data doesn't quite tell the story that the book wants it to tell. So this is what I mean. So correlational data is the worst version of nutrition research. And I say that as a basic scientist. When I say that I'm a basic scientist, I mean that I do one thing to a model, whether it's cells growing in a petri dish, whether it's animals living in the animal house, the vivarium that we have here on campus, or whether it's a human study that I'm doing. I will look at this model and change one thing and try to keep everything else the same and then see what happens. And so I can have a high degree of confidence in saying, okay, this one outcome that we saw happen is because of this one thing we did. That's basic research, sometimes called clinical research. Correlational research, which is the entire basis of the human aspect of the China study, basically you go into a population and say, answer this survey of questionnaires. Answer, what do you eat in any given week? Sometimes it's like, what do you eat in a year? I mean, these are horrific questionnaires that have the potential for all kinds of nonsense to be baked into the cake. And then they will just look at what people are dying from or what diseases they're getting in that same geographical region. Well, there are all kinds of problems with this. So just with the China study, and then I'll mention a sort of closer to home Utah sort of quirk to this, the challenge is that the China study found that higher animal protein product consumption led to changes in cholesterol, and those changes in cholesterol correlated, I shouldn't say led to, that's not the right word. Higher animal consumption correlated with changes in cholesterol, which correlated with changes in cancer risk. So A correlated to B, which correlated to C. However, they did not find that A and C were correlated.
Right.
They had to do this kind of indirect correlation to present the story they wanted. Again, heavily biased, heavily influenced by the main scientist's son, who was already living a vegetarian diet. So a lot of bias baked into the very premise there. Second, one idea that challenges this is idea right from the United States, where a lot of people talk about the magical blue zone of Loma Linda, which is this Seventh-day Adventist hotbed. Now, I do want to discuss this truly compassionately and diplomatically, because I don't mean to launch fiery arrows or disparage any religious group. Being a member of a religious group I'm about to mention, I'm very, very sympathetic to someone mocking or teasing another religion. So a central tenet of the Seventh-day Adventists is to avoid meat. Mm-hmm. And people will look at that population and say, boy, look at their lower rates of cancer. Isn't it amazing? It's because they don't eat a lot of meat. And yet a really inconvenient truth is you can look at the Church of Jesus Christ of Latter-day Saints, also known as the Mormons. Well, wouldn't you know it, their rates of cancer are just as low as the rates of cancer in the Seventh-day Adventist group. And yet the latter group eats a lot of meat. In fact, on par with about a national average. So there's no reduced consumption of meat whatsoever. And so this presents this idea that maybe there's a lot of confounding variables, that really what may end up predicting the lower risk of cancer is these happen to be populations where they avoid tobacco products, they avoid alcohol, they don't engage in risky behavior, sexual behavior, and they have a strong social community, which also really correlates with living a long, healthy life. And so the whole premise of the China study, I believe, is based on very faulty data and with a very biased conclusion. But we have better, more controlled studies that not only reject the premise, which is that animal foods cause cancer, but now and more with the explosion of ketogenic diet research, we actually have evidence that rejects all of that correlational evidence, suggesting in very direct clinical basic research models that if you put that organism into ketosis, which is going to generally be a higher animal consumption based diet, it is not only not increasing the risk of cancer, it's actually enhancing the reversal of it.
Yeah, that makes a lot of sense. And I like the newfound evidence that, I always try to help people see that lack of evidence isn't the same as evidence of lack. Just because there aren't a lot of studies done on dietary and metabolic approaches. Obviously, you leading the way, Thomas Seyfried, I think all that's changing. But, doctors like to say, well, there's such little evidence that supports it, but there's also there's also very little evidence that doesn't support it, that shows the opposite. And so I guess since we're running up on time, which is unfortunate because this is...
No, I'm like, I'm just... I'm like...
with the ketogenic approach and with the metabolic approach, are there, I know the people that will listen to this, they'll always have a question of, well, what about my specific cancer type? Are there certain types of cancer or locations of cancer where, what are the very, very edge cases, if any, where it just, if this is your situation, I would have pause to recommend this. And yeah, I guess we'll start there.
Mm-hmm. Yeah. So I presented at the very beginning of the conversation sort of two evolutions of the metabolic view of cancer. My own view articulated in Why We Get Sick, which is the combination of the high insulin and the high glucose. And then Dr. Seyfried's work more with the direct mitochondrial kind of transplant studies, certainly all of which complement each other. So these are not in comparison or in competition. So with the first view, I would say breast cancers and prostate cancers appear to really fit well into that insulin glucose centric paradigm of cancer. So if someone who's received those diagnoses, I would suggest you may benefit by looking at those variables and leveraging them, which is easy to do. It's just a low carb diet. And the same applies for Dr. Seyfried's work. He has found that the most responsive cancers to really accelerating ketones are brain cancers. And that is probably just reflective of what appears to be a physiological reality of the human body, which is of all the tissues of the body that appear to love ketones the most because of how readily they consume them, it's the brain. The brain thrives on ketosis to the point that there are people that are curious about this, and yet you're not really ready to adopt a really low carb diet. You may be interested in some of the exogenous ketones like Ketone IQ and some of these other brands that are really gaining in popularity, which I endorse sort of unofficially. I like people exploring those. Ketones are one of the most misunderstood nutrients, and yet in part because of just how beneficial they are, even when it comes to priming a cancer cell to die.
One thing I like about you, Ben, is you always said prioritize protein. Sometimes I think people, when you say ketosis, they forget about protein. That was something that was so helpful that you taught me, was we always prioritize protein, make sure it comes with fat. If it doesn't, add it in. And that combination, that 1-to-1 ratio that you talk about is really helpful. So for me, I like when you say, I don't say ketosis, but because you really do prioritize protein first, because it's that. Is that still your view?
Oh, for sure. Yeah. For me, if anyone left this conversation with a key takeaway, it would be control carbs. Like, stop getting all your carbs from bags and boxes with barcodes. Number 2, prioritize protein. And then, as you are expressing, Carly, don't fear the fat that comes with that protein. That to me is the paradigm to improve metabolic health, including reducing the risk of cancer.
Also, one last question. Sorry. Fasting. How can you execute fasting safely if you wanted to? And what are your thoughts on cancer patients doing it? Is it just, do you suggest long fasts, or do you think that, shorter fasts are just as helpful, or any thought?
Yeah. So I have to be careful. So I am speculating because there aren't studies that I can sort of cite off the top of my head, because none have done this. None have asked these questions and studied it. So everyone, please know I'm speculating. I think fasting could be therapeutic. I would suggest probably shorter term fasts.
Okay.
But regardless of how you fast, person listening, remember this: how you end your fast matters more than how long you fast.
I know. That's why I always break mine with health.
Yeah. So keep those ideas in mind. Control carbs, prioritize protein, don't fear fat.
And how do you end it?
So that would be it. And so I would say, honestly, like, if I could distill it to the simplest idea, it would be beef. Like, if I could just give the person the most clearest takeaway, despite all the insanity of this is a superfood, this berry is a superfood, this plant over here is a superfood. No, the singular superfood for human nutrition is any meat from a ruminant animal. Beef is the easiest.
What about lean beef? Not lean beef, just beef.
Well, beef, just eat it.
Okay. I love the simplicity of your protocol and everything. That you freed me from food. You freed me from counting calories.
Oh, good.
I've been teaching my friends how to do it. Even the last week, I just put a glucose monitor on them and taught them the framework you taught me. One girl's lost 6 pounds and she thought that she could never lose weight. And they're like, Carly, you're a miracle worker. I'm like, actually, it's Dr. Bikman. Give him all your book.
Carly, you are the vehicle for you are the avatar of my ideas.
Your ideas. I'm like, yes, it's
what I can't do, because I don't have that direct interaction, you are doing. And in all sincerity, that to me is the perfect idea. That's the perfect way to do it.
Good. Well, any way that we can promote or help or whatever you need, I've always been Team Ben. Seriously, I'm so
Thank you so
grateful.
much. I have about 50 questions that we never got to,
I
so
know.
we may have
Round
to
two.
do.
That'll be round two.
Yeah,
Can you say what the next book is on, or is it?
Oh yeah, for sure. Yeah. So I'd mentioned to Raleigh off the air that I'm working on my next book called actually The Case Against Carbs, where in Why We Get Sick, I look at the whole insulin effect of the high carb diet. Now I'm looking at the very substance of the carbohydrates themselves, talking about the problems with hyperglycemia, the problems with glycemic variability, the problems with the fructose, with the anti-nutrients that are inherent in all carbohydrates that we eat, these actual molecules that hurt our intestines and prevent our ability to absorb minerals like magnesium and calcium. So I'm presenting the view that despite our decades-long war on fat, we picked the wrong villain.